Okay, let's start with our video on answering problems related to force with angle along a horizontal plane. This time we have push as our force, or FA, applied force. So draw a free body diagram on a horizontal plane. So first we start off with the rectangle and or just a simple shape, preferably a box or a square or a rectangle, and label all the force acting on the object horizontally and vertically while pushing down with an angle of 40 degrees parallel to the surface. So you have something like this again. This time, because it's push, the force will go this way, and the angle produced will be this 40 degrees. So aside from that, there are, well, wait a minute. Okay, so yeah, this is going to be our general illustration, but in numbers 1 and 2 we'll have different scenarios. We have different values in terms of mass in particular, as well as the force. So we have 50 degrees instead of 40. Not sure which said 40 there, but yeah. Applied force is 25 newtons. The mass is equal to 5 kilograms. Let's see if I got it right so far. Okay. Yeah. We're gonna have to articulate our illustration a bit. So, let's say this is our, that's our applied force direction, the line. And then this is, these will be the the FAX and FAY respectively. What else do we have to add? Okay. Preferably friction, enumerate the friction, the weight, the normal force, and well, this is already the applied force, so we don't have to write anything here. Okay, now calculate FAX and FAY. So it's these two. So FA is equal to what? 25 newtons. Cosine, what's the theta value? It's said to be 50 degrees. And one more important detail is that 50 is supposed to be here. The theta is supposed to be parallel to the horizontal surface. So these two lines are parallel. So 50 degrees. FAX is equal to 25 cosine 50. So we have 16.06969 newtons. FAY is equal to 25 newtons sine 50 degrees. Okay, so that's it. Let's go to letter B. Calculate the weight of the object. We know that the mass is 5 kilograms, and gravity, always a constant, is 9.8 meters per second squared. Kilogram times meter per second squared is Newton. 5 times 9.8 is equal to what? 49. Okay, so we found the weight. Let's move on to the next. So calculate the normal force of the object. So a piece of block is being pushed. This is the surface, And well, the force with respect to the vertical um, or the vertical axis, it's not flying or falling, so it's equal to 0. The normal force we don't have, the weight we do, as well as FAY. So I believe we're supposed to look for the normal force. Yes, I just read this now, and yeah, that's what we're going to look for. FAY is 19.15111 newtons minus the weight. Weight is 49 newtons. Okay, so 19.15111 minus 49 is equal to, well, if you transpose to the other side, it's gonna be positive 29.84889 newtons. You can opt to change the symbol for normal force into Fn instead of N to avoid confusion from the symbol for Newton, the unit value. So far so good. So given that the frictional coefficient symbolized as this symbol is equal to 0.1, we have to look for the friction. Now we already know the normal force, so 0.1 times, well, 29.84889 newtons. Okay, so 84889, 0.1. Okay, the answer is 2.98489 newtons. Okay, so that's for friction. Let's calculate the net force reference to the x-axis. Is the object moving? That is a question. With respect to the horizontal surface. Well, let's find out. We already know the friction as well as the FAX. So, what is our FAX? 16.06969. What is the friction? 2.98489 newtons. So summation Fx is equal to what? It's equal to 13.0848. It's a positive value. Therefore, the object is definitely moving. The push force or the applied force is greater than the force of friction. So now let's calculate the acceleration. Given this formula, we can write it this way, since we're looking for acceleration. And then I think the mass is 5, right? Yes, it's 5. So 13.0848 newtons divided by 5 kg. What is that equal to? 2.61696 meters per second squared. So basically newtons over kilograms is equal to meters per second squared. I can't really justify that, but I'd rather memorize. So that's it. Number 2. A system of a 20 kg box pushed down with a force of 30 Newton at a 25-degree angle. So we're still the force is still push, so we have something like this. So FAY is over there, FAX is over there. FA is equal to 30 newtons. The angle is 25 degrees. Now, the frictional coefficient is 0.25. So basically we're doing letter A during the free body diagram. What's the weight? 20 kilograms. Okay, so we do have a surface which is there, and yeah, I think that's it. Well, put the weight, the friction, and the normal force. Okay, so far so good. So what is the summation of force parallel in the horizontal plane? Summation of force parallel horizontal, that is for x. So summation of fx, that's equal to fa minus friction. But basically before that, we have to calculate fax and fay. I didn't write the formulas this time. We'll write it live. So fa, I believe this is cosine theta because it's x. So x cosine theta. That's one way you can memorize. And for fay, fa sine theta. Y is the sine. Am I right? Yes. Okay. So fax, fa is 30 newtons, cosine 25 degrees. Fay is 30 newtons, sine 25 degrees. And what is fax? It is said to be 27.18923 newtons. For fay, it is said to be 12.67855 newtons. Okay, need more space. Not to avoid making the solution paper too crowded. Okay. What else is next? Okay, we can find the weight. Weight is equal to 20 kilograms. Gravitational acceleration is 9.8. So weight is equal to 196. Well, yeah, I won't box it. I'm supposed to encircle it since it's not the final answer yet. Alright, I'll just look at the answer key. See what formula was utilized. Okay. Yeah, we're going in the right direction. So we found weight. Let's move on to solving for the summation of no. We should look for
Actually, all of this is without
oh yeah, by the way, I do have to tell this. If the force is like going down like this, then the formula is supposed to be this. It's a different story if the force is like pushing from below, not from above. So one of these is gonna be a positive sign instead of minus. Oh yeah, found it. So we do have 3 types of friction: static, sliding, rolling. More on that later. But yeah, the object again is not flying or falling, so this is definitely 0. Normal force is missing. Fay is 12.67855 newtons. Weight is 196. So add those two values. we have 208. Of course, this is going to be negative here, but moving to the other side is going to be positive. Okay. Next. Hang on. Okay. So, before that, we have to look for friction. Now that we have normal force, and in the first place, we were already given what the frictional coefficient is, which is 0.25. We multiply it with the normal force, which is said to be 208. Okay, so we have 52.16964 newtons. And the formula for summation fx is fax minus f. Although in another denomination, it's supposed to be applied force minus friction. I suppose that applied force is supposed to be fax. There has to be a reason. I just justifying it right now isn't just a possibility for me to do. So fax is 27.18923 newtons minus friction, which is 52.16964 n. Summation fx is equal to, okay, so 27.18923 minus, this is definitely a negative value, what our answer is going to be. So we have negative 24.98041 newtons. So since it's negative, it's definitely not moving, the object, with respect to the horizontal surface. So now let's find acceleration. So F is equal to ma, such that force can be written as F summation fx, I suppose. Yeah. Am I right? Yeah, that's correct. Okay. A is equal to summation fx over m. So negative 24.9841 newtons over mass. Mass is equal to 20 kilograms. So acceleration is negative 1.24902. Okay, so we're done with all the computations. Now we have to identify what type of friction is in our scenario. I have no idea. Wait. Yeah. Okay. It makes sense. Our scenario is classified as static friction for the reason that unlike the other types, in sliding friction, there's a sliding motion. So definitely the surface is not even. I mean, the surface isn't straight. It's in a somehow in a slope. So that's sliding friction. And for rolling friction, well, the object is supposed to be round, but in our case, the object isn't round. So it's static friction for our scenario. Okay, that's it for this video. I'll see you in the next for tension. Wait, I do have to clarify this part. Hang on.
Okay, there. 6 pages.
Okay, I do have to fix this first before I end the video. So FAX, FAY, 40 degrees, and then we have weight, friction, and the normal force. And then this is FA. Okay, that's it. Thank you.